Hi guys, welcome to God Academy. In this lesson, I'll take you through one application of the Moivre theorem. This is a very beautiful application of the Moivre theorem. It helps us to simplify complex numbers to the power of any number, as well as its relationship with its multiplicative inverse. Let's start with the first problem. So number one, it says prove that z to the power n plus its multiplicative inverse z to the power 1 over n is always equal to 2 cos n theta, right? How do we prove this? What is z, right? So you know that z is an arbitrary complex number, say x plus iy, right? So this expression now becomes, so for this one, let z be in the cosine, right? Since we are expressing it in cosine and sine, so let me compose z. We realize that every z is equal to, now let's use a z with a modulus of 1, okay? So that things will be easier. So our z is going to be cos theta plus I sine theta. This is a basic complex number, right? So what do? We replace this with cos theta plus I sine theta all to the power n plus 1 over cos theta plus I sine theta. Realize that at this point, we can apply the Moivre's theorem, which says that, sorry, all to the power n, which says that you simply have to multiply your power by your angle and you are done. So this gives me cos n theta plus I sine n theta, right? Plus, now let's make this an inverse form, okay? Cos theta plus I sine theta all to the power negative n because it's power, right? So when I push this forward, I'm going to have cos n theta plus I sine n theta plus cos negative n theta plus I sine negative n theta, right? So this expression gives me cos n theta plus I sine n theta. Then if you have cos n theta, I can push the negative out, right? So I'm going to have, sorry, remember cos is an even function, right? So cos is an even function. So I'm simply going to have plus cos n theta, right? Then minus I sine n theta, okay? So this happens to be cos n theta, cos n theta. I'm going to get 2 cos n theta. Then I'll have this canceling this. Therefore, this and this are the same, so it is proved, right? So you can clearly see that we are getting this as proved. Let's do that for the minus, okay? So I'm going to have my number 2, z to the power n minus 1 over z to the power n is equal to 2I sine n theta. How do you prove this? I think it's just a change of operation here, so you can clearly see. So I'll simply have cos theta plus I sine theta all to the power n minus 1 over cos theta plus I sine theta all to the power n, right? So I can have this to be equal to cos n theta plus I sine n theta minus cos negative n theta plus I sine negative n theta, like this. So I just decompose this and I'll get cos n theta plus I sine n theta minus, so this becomes positive, okay, minus cos n theta because cos is an even function. Then minus, here becomes plus because minus sine I sine n theta. So cos and cos goes and you're left with 2I sine n theta. As simple as that. So this is one typical application of the Moivre's theorem. See you in the next or in subsequent lessons. Don't forget to subscribe and share.